Next, we are going to look into deployment 101. So till now, we have learned how to containerize an application. We learned about how to deploy to the Kubernetes cluster, which is basically a single node cluster. And then section 3, we have covered all around how to use OpenAI plugin to deploy a pod, ReplicaSet, and now deployment. Okay, now if you look at ReplicaSet earlier, right? ReplicaSet has one major drawback. Do you know that? Now think of it as like once you select the pod that are managed by ReplicaSet, the problem is you can't change their pod temp. So here is an example. Now look at this manifest file where we have a ReplicaSet as a Kubernetes object. We have a container by the name Ajeet Raina / to-do as a Docker image. Now think of it as like if I have a to-do application of version 4.5 and if I want to go ahead and update it to 4.6, what will happen? If you are not using deployment, then most probably you are deleting the replica set and recreating it. Now when you restart these pods, it causes a downtime till the images are available and pods are running. So a deployment resource, what it does, it basically uses a replica set to manage the pod, and it helps you to update it in a controlled way so that you don't really have a downtime for it. So what is deployment? Now Kubernetes deployment resource uses ReplicaSet, which I have already seen. So it is a higher level resource that provides a declarative updates and management of ReplicaSet. So in a single manner, you can say like Kubernetes deployment, it offers a robust and flexible mechanism for managing or deploying your application. It simplifies the process of updating and scaling your application, providing the versioning as well as the rollback capabilities, and ensuring that you have a high availability and reliability in your Kubernetes cluster. So how does it work? So usually it works in such a way that you describe your desired state in a deployment, and deployment controller changes the actual state to the desired state at a very controlled rate. And during this time, what you can do, basically and the way how it works is you define this deployment to create a new replica set or to remove the existing deployment and adopt all your resources within a new deployment. So in one way, the difference in between the replica set is that replica set doesn't provide you with updates and rollbacks, right? If I want to update from 4.5 to 4.6, then most probably you have to just go ahead and bring down the replica set. So, and even it doesn't provide you with the rollback. So we are going to look at each of these features one by one. So let me go ahead and look at this. So this is the picture which depicts. So for a deployment, so the one question which I have is, do we really need to create the 3 different manifest file for each of them? One is services, one is deployment, one is pod. No, you can have a single deployment manifest file, and you can create all those different objects. Now let's talk about the feature of deployment and how it is useful. The first feature is declarative update. Now deployments enables declarative updates to your application. You define the desired state of your application, and Kubernetes will handle the details of updating and maintaining the desired state. The second one is rolling updates and rollback. Now deployment facilitate the rolling updates. It allows you to update your application without incurring the downtime. So there is no downtime during the deployment, and during this rolling update, your new pods are created with an updated configuration while your existing pods are gradually terminated. So if an update causes an issue or failure, you can always roll back to the previous stable version. The third one is replicas management. Now deployments, what it does, it basically manages your replica sets. It ensures that a specified number of replica pods are always running at all the time. So deployments automatically handle those scaling of the numbers of replicas up and down based on the desired state, enabling the easy horizontal scaling of your application. The fourth one is versioning and history. Deployment maintain a history of all the changes made to your application configuration. So each update basically creates a new replica set with a different version, and this history allows you to view and manage different versions of your application and easily roll back to the previous version if required. Now the fifth one is pod template specification. So deployment also takes care of, it defines a pod template that specifies the desired configuration for the pod managed by deployment. So it means that this template will include details such as container images, resource requirement, you have environmental variables and more. Then the scaling comes into the picture. So deployment also supports scaling. the number of replicas pods up and down based on your application requirement. As deployment takes manages a replica set, you can always go ahead and scale your deployment by updating or by using a kubectl scale command also, as we have. Now we already talked about close to round 6. The seventh feature is the health check. Now deployment also performs health check on pods, and that ensure that they are correctly running. Health check includes readiness props, which determines when the pod is ready to serve the traffic, and we have a liveness props to detect when a pod needs to be restarted. I repeat, health checks include readiness props, which helps you to determine when a pod is ready to serve the traffic, and liveness props, which detects when pod needs to be restarted. There is also concept of service discovery and load balancing. So deployment can be exposed using services, which we are going to look at while we talk about services 101, and this provides a stable network endpoint for accessing the pod. So services enable load balancing and automatic service discovery within the cluster. So by leveraging these features, your Kubernetes deployment provides you with a flexible mechanism for managing and deploying your application. Okay, now there are different types of deployments, and we will go through them one by one. Now the first deployment model is definitely it is not the default one, but it is always important to know. So as it is mentioned in the in recreate deployment, what we do, we fully scale down the existing application version, right? Even before we scale up the new application version. So definitely you can think of it as like there is a downtime. So in the example which you have seen, version 1 represent the current application and version 2 represent the new application version. So when you update from current application to new, you first scale down the existing replicas of version 1 to 0, and then concurrently deploy replica with the new version. So if downtime is not an option for you, definitely I won't recommend this particular type of deployment, even though it is easy to set up, but there is definitely a downtime for this. Now the next is rolling updates. Now rolling updates is basically the default updating strategy in Kubernetes. So you in the picture, if you can see here, in this deployment strategy, what we do, it basically we replace the pods one by one of the previous version of our application with the pods of the new version without any cluster downtime. And this is done in the slow way, right? Think of it as like a rolling deployment slowly replaces the instance of the previous version with the instance of the new version of an application, right? And you can see here that we have version 1 v1, and then we push v2. At one point of time you bring down one of the replicas, right, and with the new version without any cluster downtime, because now your application might be pointing to the other node, to other version of your application, and then slowly you replace the second one also. So even though it is a very slow process, but it ensures that you don't have a downtime. So this is all about the default rolling. Now you have a Canary deployment. So this is an ideal deployment method for someone who wants to test a newer version before it is deployed 100%. So in this method, what happens that you basically shift your traffic from one version to another. So in Canary deployment, what happens that your newer version of application is gradually deployed to the Kubernetes while getting very small amount of live traffic. So think of it as like, say if you have three different servers and you have a 3 different version of your application running on top of it. So what do, you basically redirect half of your traffic to the older version till the time the newer version get updated, and then slowly you redirect to the newer version. So in this approach, definitely there is basically you set up 2 identical servers, you have to do it, and where you have a half of your current users pointing to the current to one of the server, and then another half with the new features that get rolled out. And when you examine that there is no error which is reported and you are confident enough, so the new version get gradually roll out to the rest of the infrastructure, and in the end all your live traffic goes to the canaries, making a canary version the newer production. Now the most popular one is a blue-green deployment. So in a blue-green deployment strategy, we call it as the red-black, green-blue. We also call it as a red-black deployment. So the blue represents the current application version, and green represent the new app. So in this, only one version is live at a time. So traffic is routed to your blue deployment while green deployment is created and tested. After we are finished testing, then we route that traffic to the newer version. So after the deployment succeeds, we can either keep the blue deployment for a possible rollback or decommission it. Alternatively, it is also possible that you deploy a newer version of an application on this instance. In that case, your current blue environment serve as a staging area for the next. Now this technique can basically eliminate downtime as we faced in the recreate deployment strategy. In addition, the blue-green deployment also reduces the risk. If something unexpected happen with your newer version on green, then we can immediately roll back to the last version by switching back to the blue. So there is an instance rollback, rollout. We can also avoid versioning issue. The entire application state is changed in one deployment. Now these are the different deployment types. Definitely in 101 we can't go ahead and cover all of them, but if you are really interested, I would suggest you to go to kubelabs.collabnix.com and try to look at each of these examples. Now with this, we come to the part where we are going to show you how the manifest file for deployment look like. We have already seen for the pod and replica set, and the way how we are going to do right now is look at few of the examples. So this is one of the example here. This is very simple example of Nginx app. Definitely we are going to use to-do list application, but to show you that in the deployment manifest, the interesting part is we don't have anything called as replica set. So replica set is not required component when using deployment in Kubernetes, because deployment automatically manages those replica set under the hood and ensure that you have a desired number of replica pods which you want to maintain, and it also handles the scaling, rolling updates and rollback. Therefore you don't need to explicitly create a replica set when using the deployment here. Okay, so you can see in this manifest file you have a deployment call as Nginx deploy, right? And this deployment basically is added to the existing replica set definition here. By including the deployment, you can now manage the replica set through the deployment resource, and it allows for an easier update and scalability. Okay, and you can, the rest of the things looks same. We have a 3 replicas of Nginx. There is the label called as app Nginx, right? And then you have a pod. Inside the pod you have a container of Nginx exposed to port 80. So let us get into our terminal and try to see how we can set it up. Okay, now one of the things which I am going to do here is I will try to use an OpenAI. Okay, so this is an OpenAI command which I am using, kubectl AI. You create a namespace called as ns3, then create a pod with container name to-do list using Ajeet Raina to-do as a Docker image. Create a deployment by name to-do deployment that manages 4 replicas of the container image, and then the replica set should manage pods with the label this. Now one of the change which we are going to do right now is try to deploy this particular deployment. So let us go ahead and try to run this. So most probably I'm expecting that it will create a deployment object and the rest of the things remain same. We have the labels are same, we have a Docker image. So let us look at this particular objects which it has created. Okay, so the manifest which it has generated has the first section is the namespace. You provide namespace. This is for pod, the single manifest file. You have a pod, and then this is for whatever is highlighted here. Okay, now let's go through that one by one. Now the first section which I have highlighted, basically it shows about the namespace. It creates a namespace by name ns3. You remember in the last example we have already deleted namespace, so it will create a new namespace called ns3. Namespaces provides a way to organize and isolate your resources within Kubernetes cluster. Okay, now the second one which comes is pod. This section which I am highlighting right now is basically a pod. The pod name to-do list right here with ns3. So the pod will be created under the ns3 namespace. The pod includes a single container by name to-do-list with the image Ajeet Raina /to, the to-do list application which we created our early section. The third section, which is the point of interest for us, is deployment. Now this section it defines a deployment named to-do deployment within an ns3 namespace, which you see right here. The deployment manages the creation and scaling of the replica set, ensuring that you have 4 replica pods which are running. The deployment also select pod based on the label selector role equals to web. The pod template within the deployment specifies a container name to do list, right? And with the image Ajeet Raina to do. Now to deploy this manifest, either I can save it as deployment.yaml or apply it directly here. So what I'm going to do right now, I'm going to apply this. Now, once I apply this, Kubernetes will create all the three objects: namespace, pod, deployment within a specified namespace. Okay, and the way how I'm going to look into it is I have get deploy -s ns3. So you can see here there are three of the deployments. There are four of the replicas which are up and running here. Okay, and if I really want to describe this, so we have a command called as kubectl describe, and it will show me that it has scaled up the replica set to do, right? And to do deployment is the name of the deployment without any error message. Now this looks good, right? Think of it is like if I want to go ahead and update the Docker image. So let us do something. I will pick up the same application which I have. Okay, and this is a to-do list application. I will go to src, go to the static, and under the JS I have something called as app.js, right? So one of the things which I am going to do right now here is make certain changes here. So I will add no items yet, please add one above more. And what I'm going to do, I made a change in a UI front end, right? And what I'm going to do, I'm going to build this version with 4.6. so I am modifying basically whatever the image which I have added some kind of modification to the front end, and now I am building a new Docker image, and I want to use that image to show you an example of deployment. So right now if you see, there is a new image. I am going to push this image to the Docker Hub just to allow my Kubernetes cluster or kubectl to fetch the latest version of my image. Think of it as like there are certain changes which was made to the image, and now the newer version of image is to do 4.6. Looks good? Okay, now what I'm going to do, I already have if you remember, I already have kubectl. So let me check in the kube view, refresh it, ns3, and you can see here the to-do list deployment is already there. Right now each of these are basically running the image, and now I want to update it from the latest to 4.6. okay, so what I'm going to do, I am going to use the same stuff here, and I will say I'm going to use the same kubectl AI. So as you know that I am specifying, okay, you have to manage 4 replicas of this container image, create a deployment by name. But now what I am going to do, I am going to go ahead and pick up the different version of different version 4.6 for my image, and let us see what it does. Now it will create a very similar deployment manifest file, but this time with a new version which is 4.6, right? So right now if you see the 4.6, I want to apply it, and once I do apply, then let's see what happened. I will use kubectl get deploy and ns3, and I will say describe ns3. So you can see here there are certain nodes which are going up and down, right? And let us see what happens here. Okay, describe deploy ns3. Let me go ahead and display. So there are 4 different replicas of this. I'm just waiting for the things to change, and if you see here, it has already downloaded 4.6, which I can verify here. If I click on this, you can see there is basically an upgrade from from to do latest to 4.6. This is basically what the deployment does, right? And if I really want to go ahead and try to port forward and try to access it, I can still do that. So if you look at ns3, there is to do deployment, right? I can always go ahead, and if you really want to see the changes in terms of port forward, so right now I can pick up any of the pod. Say if I pick up this pod and port forward to do deployment. So think of it as like, if I'm using this port forward, and then I need to specify ns3. So I port forwarded to 3000, and if I go to 3000, you can see it already, earlier it was no items yet, add one above, and now it shows please. So in this way you have seen the deployment. It controlled how you update your pods or the images, right? And then how it manages your replica set. Now as a tradition, we always do that. Don't forget to go ahead and delete the deployment. So let me see what is the name of the deployment. So I will say kubectl get, it's a -n ns3, so to do deployment. So I'm just going to go ahead and say to do -deployment and provide ns3. I'm also going to say like, okay, delete deploy, and this gets deleted, and also ensure that you also delete the replica sets under the ns3. So right now there is no replica set, so we are good. I can verify to the cube view here. If I refresh, I still have ns3, which I can always go ahead and delete it. So if I say ns3, it's get deleted, and by default now you won't see ns3 here. So we have cleaned up the system, right? Yeah, let us give some time and let's see if it comes up. But meanwhile you will see that ns3 is already deleted. So with this our deployment topic is done. In the next section we will talk about services 1.